So let's begin. Welcome all to today's discussion of Educational Codeforces Round 145 Div 2. We will be discussing first three problems. So let's begin.
वो हो रहा है ना उसमें पेपर चेक करना अगर मैं यहीं पे जाता हूँ ठीक है okay, so let's start with our problem number A. So this problem simply says that we are given four colored light bulbs, and for each index of that SI, the color of ith bulb is given. So what is our task? Our task is to turn on all the bulbs. Okay, so initially all the light bulbs are off. So but the thing is that restriction is that means here is the restriction that you can apply the operation on the light bulb if and only if the previous operation was applied on a light bulb of different color. Okay, so let's understand it this by the test case. Okay, so let's understand the first test case. So the first one given is 9 5 4 6. So here 9 5 4 6. So we can see that all the colors of the light bulbs are different. Okay, so just suppose firstly I have turned on the this one. So I have turned on this. So these all are off and off. So in first case I have turned on the first bulb. In the second for second operation, what I am doing, I am suppose I am turning on the bulb 5. So what will happen? This is on, this is on, this is off, this is off. In third case, what I can do? I can do this is on, this is on. Just suppose this is on and this is off. So in fourth, on and on. So we can see that in this all our bulbs have different colors, and we need 4 operation to turn on all the bulb. Okay, so if we go for the second test case, that is our 0 0 0 0. So what will happen? Just suppose in first test case I turned on this one, all of my other bulbs are off. So just suppose I want to means turning on the other bulb, but the problem here is that if I select any of these three, then it has the same color as the previous one. Means if you look at these three, then this three has the color value 0, and the previous one which I have chosen has also color value 0. So for me it is not possible to select the next bulb. So here I have to means return -1. Okay, so this is the test case 2. If I go for the test case 3, that is 3 3 1 and 3. So just suppose in the first operation I turned in on, off and off. So since I have chosen 3, so in next test case I have to choose the color which is different from 3. Then I have only one possibility, that is 1. So in second operation, what will I do? I will do on and off. In third operation, what I can do? I can choose a color, a bulb whose color is different from 1. So I will choose the third one. So for that, what I will do? This is on, this is on, this is on, and this is off. Okay, but here I have to be careful about that. Now I have chosen 3, but now again I have only one option, that is the bulb which has color 1. to choose, and if it is already on, then what I will have to do, I will have to make it off. Okay. In fifth test case, what I can do, I have chosen one, then what I have other possibilities of three, so I will make it like that: on, off, and on. In sixth one, what I will do, I will simply make it on, on, and on. So in these six ways, we can see that at the sixth operation, at the end of sixth operation, we have all the valve which have turned on. So this is the total number of operations. So what we can think here is that can we get means more than six number of operations. So answer is no. We can't get more than six number of operations here. Just a minute. So what we can see means we can the max operation which we need for the given string is 6, which we have seen here. And just suppose we have all the elements which is same, then we need means we can't do, so we will return -1. If we have all the elements of the string same, then we are going to return 4, and we have, if one element different, then we are going to return 6. In all other cases we will get answers 4. So let me take another test case that will help you. Just suppose I am taking two element different, 2 1 2 1. So what will happen in first test case, means I am turning on 2, other ones are off. So now I have chosen 2, then what I have other options, I have to play with light bulb whose value is 1. So I will want to on, off, off. So now I have chosen 1, then I have to choose 2. So in third case, what I will do, on, off, and in fourth one, what I will do, I will make the remaining bulb on. So you can see that after in means all other cases, the operation which we need is 4, and that means that is all the possibilities which we can see. So if you want to see the code for that, then just a minute. I am yeah. I am just showing the code. Just a minute. Okay, so here you can see that okay, so this is the string which is given in the question for each test case, means this is the T here which represents the number of test cases, S is the string, we have taken the input here, and whatever we are doing, we are storing the every character of the string in a vector. Okay, so this is the vector, and we are storing the every element of the string in a vector. After that, we have sorted the vector which in which we have putted the element. Okay, so what will happen after the sorting, just suppose we have all the elements equal, then what will happen means if you have all the elements equal, then after the sorting, the element at the 0th index in the vector and the third index in the vector will be same, means it is actually the first and last elements will be same. So this is only possible when we have all the characters in the strings are equal. So we have seen that we are going to get -1. So this is the first case. So if I go for the second case, so second case will be this one. Here what I have done, this is the case for 6, in which you can see that just suppose you have only one different element. So what will happen, you can see that just suppose I will show you by test cases. Just a minute. What is written there, x0 equals x2 or x1 equals x3. So just suppose I take an example like uh, 2 1 2 2. So I have when I have sorted this, then how x will look like? X will look like this: 1 2 2 and 2. So you can see there. Okay. Yeah. So you can see here. Means what is x0? So x0 is 1, x2 is 2, x1 is 2, and x3 is 2. So the condition which I have written here is true. So means this is the condition for one element different and all the three elements same. So in this case we are going to return 6, and I hope so I am sharing that. Okay. So that is for the case number 2, and if I go for the other if else, just a minute. Yeah, for the other if else, here what I have written, that you can simply suppose that all the elements here, that is if means other condition, just suppose the first and the second element of the vector is same, or the second or third or fourth, mean all the other cases we are getting 4, we are not getting more than 4 operations required for that. So this is the code for the question number A. uh, uh, if I want. Okay. So any doubt in question number A?
Can you do it without
So without vectors we can do that, but since we want to know how many different elements are present in that string, right? So for that if we are not using vector, then we can do it by map to store the frequency of a single element present in that string. So if you're we are using vector because we want to see after sorting how many elements are same, because you can see that the length of the string is 4, right? So what are the cases if you are getting all the elements same, means 0 different element, 1 different element, 2 different element, 3 different element. So you can simply see that means if there are 0 different element, then you can't, you means you can never get the desired result, so you will have to return -1. If there are 1 different element, then answer is okay, just a minute. Okay, I hope so I'm saying okay. Yeah, means if you are not sorting, so as I have told that you simply have to focus on the frequency, means how many different elements are present there. So so if you don't use vector, it is not a big deal, but you have to store somewhere that how many elements are different in that string. You can simply do it by traversing also, simply because the length of the string is 4, so it is not going to be a big deal to know that how many elements are different. When you are able to get that how many elements are different, there are simply 3 cases. If 0 different element, then you are going to return -1. If 1 different element, answer is 6. Otherwise in any cases answer is going to be 4. You need at least 4 operations to make all the light bulbs on. Okay, so any other doubt?
Okay, so now we will start with question B. Yes, so in the B question we are given that we have two-dimensional plane and we need to place n chips on it, and the cost of placing, like the cost of placing a chip at x comma y coordinate is equal to mod x plus mod y. So if we imagine it in the coordinate plane, it will form a diamond like shape. I will show you by sharing the screen. And the cost of placing all the n chips is said to be equal to maximum among the cost of each chip. So for all the n chips, the total cost is just the maximum of all the chips. Okay, so now let's understand it with on the screen. So this is our coordinate plane, and this is the origin 0 comma 0, and here we have the points, 4 points. Along these points we have the cost of placing a chip as 1. You can see that, like, this is the coordinate 1 comma 0, and this is 0 comma 1, like, and similarly. So if we place a chip along these 4 outer points, the cost is 1. And similarly, moving forward, we can have the outer points, like here. Yes, so now on the outer blue boundary, the cost is equal to 2. So like, if we have only one chip to place, so like I can simply place it on the origin, the cost will be 0. If I have two chips, so I need to place at least one chip on the orange dotted square. So the cost for placing two chips will be at least 1, so I cannot get cost 0. And similarly, for 3 chips, 4 chips, I can place on the square but not on the origin. I need to skip the origin because we have the given condition in the question that distance between each pair of chips is strictly greater than 1. So like, you can see a pattern here, like if I am given greater than 4 chips, so then I need to move on the outer square. Like, first chip I can place here, second, third, fourth, fifth, sixth, seventh, eighth, and also I can now place a chip on the origin. So totally I can place at least 9 chips and get the cost equal to 2. So if I have 9 chips, I have 2 as a cost. So similarly, let me write that down here. Like, if I make here chips versus cost, I can see a pattern that if I have one chip, the cost is 0. If I have 2 to 4 chips, cost is 1. 5 to 9, the cost is 2. And similarly, moving, we can see this pattern. So like, if you can observe here, the cost is simply equal to the square root of n minus 1, and it is actually a floor of this function, like the floor of root n minus 1. So now it is very easy for us to code this. Let me show you the code. Any doubts in this, or like any queries, things you didn't understand? Yeah, so here, yeah, the given constraint is still 10 to the power 18, so we have to use long here. LL is defined as long like you can see, yeah, here. Yeah, so this is just long. So I have defined n as long, take the input and n minus 1, and then also you have to use sqrtl, which is for long, like taking square root of long numbers. Yeah, so I simply stored it in the variable result and printed. Yeah, so any questions? Okay, so moving on to the next question.
Okay, so I will explain question number 3. So let's read the question first. You are given an array A1, A2, A3, and let's denote its subarray ALR, means like A from L to R. So it is given explanation of like what is the subarray. Like 6 subarrays are there total. So 1, 1 minus 3, 1 minus 3 minus 1 minus 3 minus 0 minus 1, and 1. So like the main question is, you are given two integers n and k. Construct an array A consisting of n integers such that like all the elements of A are from -1000 to 1000. Okay, like this is the range. A has exactly k sub arrays with positive sums. Like this is an important line. And the rest n into n plus 1 by 2, like total sub arrays n into n plus 1 by 2 minus k sub arrays of A have negative sums. Okay. So the test cases are like 1 to 5000, and each test case contain one line integer. So n, like you can see n is very small. So 1 to 30. Okay. So like let's see, understand the question using test cases. Yeah. Yeah. So see, so first test case is 3 and 2. Like we have to construct an array with length 3 such that has on two sub arrays with positive sum. So like main line here to understand is positive. So like you can consider only positive and negative sums array, sub array. Like you there in your like constructed array there should not be like any array that has sum equal to 0. This is like the main line. Okay, so let's see like how we can construct a array with only two like sub array, two with positive sums. Okay, so let's see. Okay, so like let us suppose that I have a subarray with 2 2 2 2. So the sum total number of like the subarray total either in which we have like negative sums will be, okay. So like here the length should be this, let's denote it as like m. So the total number of sub arrays in this whose sum is positive will be m into m plus 1 by 2. And like we have to find total k sub arrays which has like positive sum. So what we can do, like first let us suppose like how much we can replace it with some positive number. Let's denote it like 2. So 2 2 2 2 2, how much we can replace it, like, so we can like just find out an m such that m into m plus 1 by 2, which is like it's less than k, like largest m. What largest m we can find such that this condition hold largest m. So like we can start iterating from n till 0 and find such an m such that like this condition holds for largest m. So once we get like also let now our task will be find to like k minus m into m plus 1 by 2 some sub arrays that have positive sums. Our task will be remaining this. So definitely like this number will be less than m plus 1. k minus m into m plus 1 by 2. This number will be always be like less than m plus 1 always, because like this number is nothing but 1 plus 2 plus 3 till m, and we have finded the largest m for which this condition holds. So definitely like it will be not included m plus 1. We have not included m plus 1 because m plus 1 is greater than. So we will find such an m. So now our task is to remain the total sub arrays which are like positive but like in the range is this. So now for doing this we can do like just we can construct 2 till m length this, and for creating this we can construct like we can consider a number such that like this number will definitely lie in between this. Let's suppose I have to construct only 2. So this 2 should be positive, and like for the rest of this there should be a number such that the sum with this number, let's notice like so that sum of these numbers like till here it is like either 0 it is. Okay, so and after that it should be positive, and before this it should be negative. And after that we can consider minus 99 some larger number or like minus 1000 simply. minus or minus, we can consider those. So that like this will be our sub array that will have total so total like k positive sums. Okay. Okay. So like what will be the number this x, because we have founded m, so x will be simply like simply m minus k plus m into m plus 1 by 2, because like now we want only, so like for the last we are searching for like how many we can get the last numbers with positive sums only. So that's why we are subtracting this k minus m into m plus 1 by 2 with again m, so like we can get that length. And now, so now here one more case to consider is that because the sum of this, if we consider x as like this, the sum of these numbers will be 0, so we cannot have any subarray with length equal to 0, so like we will decrease just x by minus 1, x equal to x minus 1, so that the sum of the number still here will be minus 1, not 0, so because like it should not be 0. So yeah, like just simply, so we will print 2 till m times, and then we will print x, and then we will print the remaining numbers from m plus 2 to n. We will print some larger negative number, which is like we can print minus 1000. So yeah, like that's all the solution. I will show you the code. Yeah, like this was the code. See, like I have taken m equal to 0 here startingly, and like I am finding some larger m such that this condition holds, like this z is greater than 0, and like I have m equal to, then I like larger m and break it from here, and then like till that length 1 to m we are like printing 2, and then like if you can choose any number like greater than equal to 2 here. Also like we are taking if m less than n, like if we haven't printed all the arrays, all the lengths, then we take like this, that x denoted as r, it is x that we are printing, then we will print x, and then like some larger negative numbers. Till here like we are done with this total number of subarray with the k positive sums. We are done, like, and we are printing here some larger negative number that cannot, because like in the question you can see n is from 1 to 30, so definitely minus 999 will be always greater than, if we like consider all the sums also, then also like minus 999 will be always greater than. So like, so any doubts? Okay, I think so, no doubts.
If you even have any doubt in ABC, any one of those three questions, you can ask it now, or else you can DM us too if you want. So I think everyone is clear with ABC. So that's all for today. Thanks for attending this discussion. We'll meet you soon in the next contest. Thanks and bye.